Hi everyone, Dr. Bruce here. In this video, I'm going to cover the spine and the individual vertebrae of the spine. Sometimes students have some problems with identifying the individual vertebrae in the different parts of the spine, so this video should help you with that. I'm in my 3D model page, and I'm going to use some of these 3D models that I've been working on. And let's start with the actual spine. So let's go full screen on this. So here's the spine, and you'll see that what the spine is, it's a number of vertebrae stacked one on top of the other. There are different regions of the spine. There's the cervical region, the thoracic, the lumbar, and then the pelvic or sacral area. You'll also notice these curves. So the cervical region consists of 7 cervical vertebrae, and they're curved. They form a curve. This type of curve is called a lordosis or a lordotic curve. This is followed by the thoracic spine. This one consists of 12 vertebrae, and this type of curve is called a kyphotic curve or kyphosis. Then we get into the lumbar section. There are 5 lumbar vertebrae. This curve matches the cervical curve, so this is also a lordosis. And then we have the sacral curve, which is a kyphosis. At the bottom of the spine, of course, we have the sacrum, which is a number of fused vertebrae, and then the coccyx, which are some small fused vertebrae. So also interesting to note that these curves are called primary or secondary. The kyphotic curves in the thoracic and sacral region are the primary curves, meaning they're present at birth. So when you're born, you have these curves. The lordotic curves in the cervical and lumbar area are secondary curves. So these develop as you lift your head as a baby, and then as you start to weight bear and sit up and walk and so on, these curves develop. All right, so we're going to take a look at some of the individual vertebrae. So let's take a look at some of these. Let's start with the first cervical vertebrae, which is called C1 or the atlas. So let's let that res in here. So all of the vertebrae are sort of like ring shaped. They have what are called pedicles and lamina. And the first cervical vertebrae is unique in that there's really no body. There's no body here. It's just like a ring of bone. Another interesting thing about cervical vertebrae that you can always tell it's a cervical vertebrae is that they have these processes called transverse processes, and they have holes called foramen or transverse foramen in the transverse process. So this only happens in the cervical area of the spine. These holes are here in order to carry the arteries and veins. The vertebral artery and vein go through these holes, and it sort of protects those arteries and veins as they move into the brain. All right, so that's the C1, the atlas, a ring of bone. There are these things are called facets, the superior and inferior articulating facets. Facets are really flattened areas of the bone that form joints where they connect to other bones. Okay, let's take a look at this second cervical vertebrae. Let's get down there. All right. So this one is also unique. This is called the axis, the second cervical vertebrae, the axis. And it has a unique feature because of this process sticking up here called the dens or odontoid process. It also is like a ring shape. You know, there are short pedicles and lamina. It also has the transverse process with the foramen, like all cervical vertebrae, so the holes on the sides. And then it has a body as well, so a little bit thicker body. But you can see that this is very unique. There's no other vertebrae in the spine that looks like C2 or the axis. All right, let's go on to the next one. So this is a typical cervical vertebrae. This is the fourth cervical vertebrae. So like C3 through 7 are, look like this. So here again, we have a body. Now this has a thicker body. So this is the body. The disc sits right up in here. These are little called pedicles, and these are longer processes called lamina. This is called the spinous process. These are the transverse processes again, with the holes again, the transverse foramen. So you can see the remaining cervical vertebrae look something like this. So they have a body, pedicles, lamina, spinous process, and then the transverse processes with the foramen. They also have articulating facets, which are the flat areas where they connect to one another. Okay, so that's a typical cervical vertebrae. So let's look at a thoracic vertebrae. Here's a typical thoracic vertebrae. So you notice that the body is thicker. So these get bigger as you go down the spine because they bear more weight. The more weight that is carried, the thicker the body. So the thicker vertebral body, still short pedicles. There's the lamina. There's the spinous process. Here are the transverse processes. Notice there's no hole. There's no transverse foramen. So that tells you it's not in the cervical spine. Another unique feature of thoracic vertebrae are these facets on the body. So these are articulating facets for the ribs. So the ribs attach to the thoracic vertebrae. Okay, so you have your superior and inferior articulating facets, and then you have the facets on the body for the ribs. Okay, let's look at a lumbar vertebrae. All right, lumbar vertebrae, the biggest or thickest body, the biggest body. Look how big that is. The disc sits right on top of this. They're the biggest because they bear the most weight. So that's why they're there. Also, the short pedicles, the lamina, the spinous process out here, and then the articulating facets, just like we saw in the other vertebrae. So lumbar vertebrae, the biggest of all. Those are the largest bodies. So that would help you identify, the different vertebrae. Okay. So that should do it for this video. Hopefully that will help you in identifying the individual vertebrae of the spine and the curves of the spine. So hopefully, I'll put the link in to this web page if you'd like to take a look at these models. You can take a look at them anytime. And hopefully this will help, and we'll see you in cyberspace.